Hi everyone, Simul here, back again with another LeetCode problem. And today we are going to take a look at problem number 141, linked list cycle. Despite being an easy problem, one of the approaches that's taken to solve this problem is one of my favorites. That's why I'm really excited to make this video. So let's just directly jump into the problem statement. So we are given the head of a linked list and we need to determine if that linked list is a cycle or not. So how do we know it's a cycle? It's a cycle if we traverse starting from the head, traverse all the nodes, and suppose we reach the last node. If this last node again points back to any of those traverse node, then this is a linked list cycle because it keeps on going on a cycle infinitely. It doesn't exist out of the linked list because it's not pointing to, none of the node is pointing to null, right? It Similarly, the linked list would not have been a cycle if this last node would have pointed to null. So the problem asks us to determine if this linked list is a cycle or not. If it's a cycle, we have to return true, otherwise we have to return false. So how do we do that? Let's just jump into the whiteboard. um, so we have a couple of nodes, right? 3204. Let's take the same example. 320 and 4, and we have the connection between the nodes and the last node. This might be a cycle. So one of the approaches, what we can do is we can take a hash map or a hash set rather with the unique values, and we'll traverse the all the nodes in the linked list, and each time we traverse we reach that particular node, we store it in the hash set. We are storing the node and not the value because the value might be repeated, right? For example, this might also be 3, this might also be 3, right? So it will be duplicated, but this is a hash set. It only stores the unique value, which if this would have been duplicate values, then it would mess up with our logic. That's why we store the node itself. So first node, we store the first node, again traverse to the second node, store that, and so on and so forth. So now after we reach 4, we again traverse to 2, which is already present in the hash set. Then we realize since it's already present in the hash set, that means there's a cycle. The linked list is a cycle, right? So that's one way we can determine this algorithm. As this technique will have big O of n space and time complexity, but there's one more better solution which actually achieves solves this problem in big O of 1 constant memory complexity, which is called Floyd's Tortoise and Hare algorithm, right? Which is one of my favorite algorithms out there. It's very simple, but it's like amazing. You just appreciate how this algorithm is. These are the algorithms why I really like working on LeetCode problems. So let's see what does Floyd's Tortoise and Hare algorithm say. So it asks us to initialize two pointers in the head. Let's call one as slow and the other as fast. So on each traversal of the node, on each step, we traverse the slow position one step, one node at a time. Whereas on each step, instead of traversing fast one node, we will traverse it twice, like double the distance of the slow. So step 1, fast will go over here. Fast will reach this node. Again, step 2, slow will move one node forward, whereas fast will move one node, second node forward. Again, slow will reach one step forward, fast will reach two step forward. So at any point during this traversal, during this loop, if slow and fast pointer meets at a single node, where that means they're equal, then we can consider we can say that this linked list is a cycle. If this was not a cycle, in this case, suppose if it was, it would have reached null, right? If this would have been null, then fast would have reached null way before than slow, right? Because fast traverses twice in one go. That's why it would have been a non-cycle linked list if this would have been done. But in this case, they will converge in one node in one point during the traversal. That's why making the linked list a cycle according to Floyd's Tortoise and Hare algorithm. So that's the algorithm. Let's just jump into the code. So we have two pointers, slow and fast, both pointing to the head, right? And then we take a condition, we'll use while condition, and what is, let's use fast instead of slow, because if fast is either fast or slow is not equal to null. But there's one more catch, because fast traverses two nodes at a time, right? So that's why we have to also check fast dot next is not equals to null, right? Then we keep on looping it. So once we are looping, what do? We traverse slow by one node, whereas fast by two nodes, right? And what is our success condition for the cycle? If slow equals to fast, we return, it's a boolean, so we return true, or this is the condition where the linked list will be cycle, otherwise we can return false. Yes, that's it. Let's just go. Oh, we already have this. Let's run. I know it should be, yeah. So there we go. We have okay, let's submit as well, right? Rather than just running. Yes, okay, perfect. So yeah, that is problem number 144. Um, Linked list cycle, which is solved using Floyd's Tortoise and Hare algorithm, which is pretty amazing. And thank you for everyone who has watched the video up to this point. A big shout out to LeetCode. His problems on YouTube and his way of explaining things have been super helpful and has given me a lot of inspiration to do this. So a big shout out to him, and all the best to everyone who's been grinding LeetCode. I think personally what I feel like is more than just grinding it for the sake of it. Actually, you know, uh, like really loving solving the issue, solving the problem, and taking the different approaches, and actually admiring the problem, which is also something that will really help you in having a good knowledge of algorithms and data structure. So thank you everyone again. See you soon in next video. Thank you.